Okay, so this is section 6.3. I'm going to do it over this PowerPoint, not all the slides. And you can read the section. I want to hit the high points. We're looking at sampling distributions now. When we have been doing individuals, I'll show you what I mean by that. Think of the Navy pilots problem in 6.2. We had a normal distribution with women. We had a mean of 63.7 inches, standard deviation of 2.9. So if we had a problem, if I pick a value here, I'm going to pick 68 inches. We could do the probability that an individual, one single X, one individual woman would be shorter than 68 inches. We would find the Z-score and then find that area. So all of the values in here that in this normal distribution are all individuals. They're all X's. And if we knew them all, like in the bears, you could find the mu, the mean of the population of bears, which I did. But it's all from individual bears. So these are all individuals. Now we're moving into sampling distributions. So look at this. This looks different. We have a normal distribution here, but look, it's now built around sample means. So think of what you did in that little kind of quiz with 6.3. Everybody took a bunch of samples. Just for the heck of it, I got somewhere X bar was 198. I got others where X bar was 207, et cetera, et cetera. You gave me a bunch of them. I was trying to reproduce this distribution. It didn't go so well for various reasons, but you'll see that on the next assignment. So we had N equals 20, our sample size. So this is huge right here. Sample means tend to have a normal distribution. And so if we had all samples of size 20 with the bears and their weights, we would get that distribution. There just happens to be a few of those. Remember this, friend? There was 104 bears. We were doing samples at 20, order didn't matter. So I only ended up with maybe 77 of them. So my distribution didn't look what I wanted it to look like. Because there's only 1.3 times 10 to the 21st samples of size 20 that we could have made from our 104 bears. Okay, I'm going to look at proportions now. And the author doesn't really introduce proportions until right now, which I always thought was strange. So I'm going to talk about the bears again, proportions. Which the proportion for a population is lowercase p. So this is for the population. And if we have a sample, lowercase p with a hat over it, p hat. So if I looked at my population of 104 bears, I knew there's 52 females, so I'm looking at females out of the 104. So the proportion of females is 0.5. I'm using P here because this is the population. This is the proportion in the population. Now suppose I did a sample. Suppose I did a sample at 20 and I got 13 bears. My sample proportion is then 0.65. So if we did all sorts of these proportions, all the ones of the size n equals 20, our distribution of sample proportions also has a normal distribution. So this is big because it allows us to do different types of problems, which we'll do in 6.4. The last thing I'm going to look at is variances. I had you send me standard deviations because I was going to maybe try and recreate what happens next. And again, for various reasons, it didn't quite turn out. But look at the distribution of sampling variances. Now remember, you sent me standard deviation, which is the square root of the variance. Notice it's not normal, skewed right. This will play a major role down the road when we're doing hypothesis testing, when we are going to have to test for normality later. Later, when we're working with standard deviation, we're going to have to test for normality, our samples and such. And the reason being, because the sample distribution isn't normal, it's skewed. So here we are, sampling distribution of a statistic. This is just kind of reviewing again. I'm going to talk about the bears. And new color. So we were looking at means, n equals 20. And if we could get all of them, the sampling distribution would be normal. And these would now all be means of samples of size 20. N was 20. So that's basically the big takeaway from this. I may scroll down rapidly, don't get seasick here. You can read this, go through the PowerPoint. It just reiterates everything we're doing, or that I did. Do not worry about those, or these formulas. Remember, we use the website to find all our standard deviation and variances. Notice they're skewed to the right here. Estimator. So really, this is what we're doing in statistics. So we will take sample proportion p hat to estimate the parameter p, the population proportion. We will use X bar to estimate the population mean. And we will use S squared, the sample variance, to estimate the population variance. Some estimators are better than others. We like them to be unbiased, so they do target the population parameter. And to finish off, here's some unbiased estimators. So they target the corresponding population parameter, just like I showed up there. Again, this targets P, this targets mu, and that targets sigma squared. Some unbiased estimators are below median range, and notice standard deviation. Later on, we're going to do tests of standard deviation, and so we really have to be careful that our population is normally distributed. And we can look at that when we do our samples. But that's for the next chapter. And that's 6.3 in a nutshell.